All right, today we're going to learn how to do a long division problem into a number that we won't know from our times table. For example, 8 into 17,265. Now again, nobody knows what times 8 equals 17,265 in their head. So you have to come up with a method to do that. And what we're going to do to figure that out is we're going to use a combination of lead digit estimate, which we learned how to do with adding, subtracting, and multiplying, and combine it with an algorithm that mathematicians came up with to be able to do the process for the whole number. So we start by saying instead of what times 8 equals 17,265, we start by saying what times 8 would equal 17,000. Okay, and again, we know that 8 times 2 is 16, so that means 8 times 2,000 would be 16,000. So you could put a 2,000 up here to get a guess. And notice the 2 is on top of the 7. All right, so we're going to use that concept to divide just 8 into 17. And remember this, the front into the front, always the front into the front. So 8 is the front, 17 is the front. By the way, you might say, why not 8 into 1? Because 1 is the front. Well, if 8 went into 1 evenly, you would divide 8 into 1. But since 8 doesn't go into 1, you have to say 8 into 17. So again, what we'll say here is what times 8 equals 17 is 2. So we would put the 2 right here, just as if it was 2,000, like we did with the lead digit estimate. And now we're going to use a process, an algorithm. That's a mathematical method to do something that mathematicians figured out that can be remembered by using this right here. Does McDonald's constantly sell cheeseburgers? And again, excuse me, what it really stands for is divide, multiply, check if too big, subtract, check if too small, and bring down. And again, that method, divide, multiply, check if too big, subtract, check if too small, bring down, can be remembered by using just the first letters. Does McDonald's constantly sell cheeseburgers? By the way, I believe last year when you were in 4th grade, Miss Welty or Miss Dwyer most probably taught you, does McDonald's sell burgers? I added the constantly cheese because as you get to bigger dividing, sometimes you're going to guess too big and sometimes you're going to guess too small. And if you don't know if you guess too big or too small, that becomes a big problem. But anyway, for this problem, the check with a 1-digit divisor is not a real big deal, but it is the process. So as we go through the process slowly, please pay attention to what you have to do. Now, first of all, we did the dividing. And remember, division is multiplication in reverse. So when I divide 8 into 17, what I'm really saying is what times 8 equals 17, or what's closest to 17 without going over. And again, if you know your 8 times table, you would know 2 times 8 is 16, which is the closest you can get without going over. So then you would go to the multiply, and you would multiply 2 times 8 is 16. All right, and then you go to the check if too big. Now, if you guess too big, it'll be easy to tell that you guessed too big. Because if you guess too big, the number you get when you multiply is going to be bigger than the number you're dividing into, which means you can't even subtract. Because you see, if I was to guess 3 times 8 is 24, and again, you can't take 24 away from 17. So it's very easy to check if too big, although I've seen people before who guess too big and don't change the guess, because in their head, they subtract 24 minus 17 instead of 17 minus 24. But anyway, for our sake, we know it isn't too big when we use a 2 because we can go to the next step, which is subtract. 17 minus 16 is 1. Now you have to check if too small. And this is the one that gets to be tricky. Usually people can check if too big without any trouble. But check if too small is a bigger problem. All right, because, excuse me, even if you guess too small, you could continue the process to bring down. But the way you can guess that you're not too small is your remainder will be smaller than your divisor. Okay, 1 is less than 18, so I didn't guess too small. Now, if I was to look, had I guessed too small, had I guessed a 1 and said 1 times 8 is 8, again, excuse me, I didn't guess too big because I can subtract. And when I subtract, I get a remainder of 9. Now, 9, it means that I guessed too small because 9 is bigger than 8. And so, oh, why don't I just do that? Because then it creates a real big problem. Because you see, if I continue and bring down when I guess too small, 8 goes into 92 11 times. And you can't put an 11 up here. And that's because I guessed too small ahead of time. All right, so again, the right guess was 2. And 2 times 8 is 16. And now I can subtract 17 minus 16 is 1. And again, I didn't guess too small because 1 is less than 8. So now I can bring down the 2. And that's how the process, does McDonald's constantly sell cheeseburgers, works. Divide, multiply, check if too big, subtract, check if too small, bring down. But now I have to repeat the process. And you go, how many times do I have to repeat the process? And I say, until you bring down the last number. So we go back to the top to divide again. All right, and I divide 8 into 12 by saying what times 8 equals 12, or closest without going over. And that would be 1. Now, 1 times 8 would be the multiplying part. 1 times 8 is 8. All right. Then I have to check if too big. Can I subtract? I can, so I didn't guess too big. So then I subtract, and I get a remainder of 4. And then the important step, check it too small, is 4 less than 8? It is, so I didn't guess too small. So now I can bring down the 6. Now at this point, I can now divide again. Again, this time when I divide 8 into 46, I'm saying what times 8 equals 46, or closest to 46 without going over. And if you know your 8 times table, that would be 5. Now, 5 times 8 is 40. And now I can say, excuse me, did I guess too big? And I didn't guess too big because I can subtract. So I subtract and I get 6. Now I have to check if too small. Is 6 less than 8? It is, so I didn't guess too small. So now I can bring down, and I bring down the 5. Now, excuse me, I start again at the top with divide. What times 8 equals 65? And again, if you know your 8 times table, 8 times 8 is 64, which is close to 65 without going over. So now I multiply. 8 times 8 is 64. Check it too big. Did I guess too big? No. 64 is less than 65, which means I can go to the next step and subtract. 65 minus 64 is 1. Did I guess too small? No. 1 is less than 8. So I can go to the last step, bring down. I have nothing to bring down. So now I'm finished. However, when you were in 4th grade, you learned to write R1, which stood for remainder 1. In my class, we don't write the remainder as just R1. Because in real life, if you had to take this answer and add it to something, or subtract it from something, or multiply it times something, you wouldn't be able to multiply times 2,158 or 1. So I have to make the 1 something that I can use. And in mathematics, you can make your remainder a fraction or a decimal. Personally, I think making it a fraction is a lot easier. And that's because all you have to do to make it a fraction is take your remainder and write it as your numerator, take your divisor and write it as your denominator, and that would be your answer, 2,158 1/8. Now, this process is what you do in every single problem. Divide, multiply, check if too big, subtract, check if too small, bring down. And again, my warning is check if too small is the trickiest step in the whole process, because it's easy to guess too small and not catch your mistake. So you always have to make sure you catch your mistake.